Okay, here we go. We're going to try this one again. We've got live video. This is going to go up on YouTube. Page 84, we're doing compositions of functions to verify the existence of inverses. Page 84, number 5, they gave me f of x is equal to 6x. I have to find the inverse in order to do the rest of the problem, which is to verify that f of f inverse of x equals x and that f inverse of f of x equals x. So the first step is to find out what f inverse is. So if f of x equals 6x, to do that, I replace f of x with y, because it's going to make doing this next several steps easy. Once I have y equals 6x instead of f of x equals 6x, I reverse the variables x and y, and I get the equation x equals 6y. To solve this for y, I either divide both sides by 6 or equivalently multiply both sides by 1/6. 1/6 times x is 1/6 x. 1/6 times 6y is y. Now that I have done that work, that y becomes f inverse of x. That's all I did. I renamed y f inverse of x, and that equals 1/6 x. Here you see me writing down what this rule is going to do for anything I give it. So f inverse of anything is 1/6 times that thing. What this discussion was about was we repeated by example that if one divides something by 6, that is equivalent to multiplying something by 1/6. So don't confuse this x with that x. That's a variable. This is a multiplication symbol. Now that I have the inverse, I'm going to verify that f of f inverse of x turns out to equal x. The first step is I still have f of. I replace f inverse of x with what I just found it to equal. So f inverse of x is 1/6 x. To 1/6 x, I do the rule of f. F takes whatever you give it, multiplies it by 6. So if I'm going to give it 1/6 x, I am to multiply that by 6. 6 times 1/6 will cancel, and I get x, and I've got the first half of the verification requirement completed. Now I do f inverse of f of x. That work's being done here. I replace f of x with what f of x is equal to, which is 6x. Then I apply to 6x the rule of f inverse. F inverse multiplies by 1/6. So giving it 6x, it multiplies it by 1/6. The 6's cancel again, and I get x. For number 17, I'm told that these two functions are inverses. My work is to verify they are by composing in both orders. I will do f of g of x, finish that work, then come over and do g of f of x, and hopefully verify the same thing. For 17, f of x is equal to x cubed over 8. G of x is equal to cube root of 8x. That means whatever I give f, it will cube that thing and divide by 8. The rule of g is whatever I give g, it will multiply whatever I give it by 8, and then find the cube root of that product. So f of g of x is equal to f of what g of x equals, which is cube root of 8x. Then I will do to cube root of 8x what f does. F will cube this, and then divide that by 8. Cube roots and cubes, when done in tandem, undo each other. So the cube of cube root of 8x is 8x. And 8x divided by 8 is x, and that's the first half of the verification process. Now I verify what g of f of x will do. First step is to substitute f of x. F of x is x cubed over 8. I then apply the rule of g. G will take whatever I give it, multiply it by 8, and then find its cube root. So I'll work inside first. The 8's cancel. Now I have x cubed under the cube root, and cubes and cube roots undo each other, and I get x. And that's the work we're doing. The assignment that was given on Friday was page 83. I kept saying 84, but I think it was 83, so I misspoke. The problems were 5, 7, 9, and 11. Also, numbers 13 through 19, Part A only. Part A only. So you need to work on that. As class wraps up, I will send you the problem that I want done. I want you to finish that problem, take a picture of it, and send it to dpileggi@cambridgeacademy.org. Again, you will send the problem I request to dpileggi@cambridgeacademy.org. I will send you the one I want by way of remind. That's it.